In today's session, we will be learning how to solve quadratic equations by factoring. Before we even start solving quadratic equations, though, let's review some grade 9 solving equation methods that we've learned so far. Consider the linear equation 2 bracket x minus 3 minus 5 times x plus 2 all equals 11. Solving this equation and any other equation means to determine the value of the variables that satisfy the equation or makes the mathematical statement true. So for the given equation, when you substitute the solution of x into the equation, the left side of the equation would equal the right side. Okay, so the solution is that value of x that we are going to find, that when you substitute it into the equation and calculate the left side of the equation, it's going to be equal to the right side of our equation. Well, let's review how we would do that. And I'm just going to rewrite our equation in the space here. So you have 2 bracket x minus 3 minus 5 bracket x plus 2. It's all equal to 11. So we want to figure out what that x value is on the right side that will make that right side of our equation equal 11. Okay, first we start with expanding out our brackets, or multiplying the constant in front of our brackets with the binomials that we have. So when we expand, we get 2x minus 6 minus 5x minus 10. And that's all equal to 11. I'm going to choose to keep all of my x variable terms on the left side of the equation and move all my constants to the right side. But again, this could be something that you choose to do opposite. So you could put all the constants on the left and put all the x values on the right. It doesn't matter. Okay, so I have 2x minus 5x, and that's going to be equal to 11. When I bring my constants over to the right side of the equation, remember the sign is going to change from subtraction to addition. Right? So instead of having a negative 6, now I have a positive 6 on the right side. Instead of having a negative 10, I'm going to have a positive 10 on the right side. Okay, simplifying both sides of my expression by collecting the like terms. On the left side, I'll have negative 3x. And on the right side, 11 plus 6, that's 17 plus 10 is equal to 27. Then, in order to isolate that x value that's being multiplied to the negative 3, I'm going to divide negative 3. Remember, division is the inverse operation of multiplication. So it essentially undoes the multiplication that is occurring between the negative 3 and the x. But whatever we do to one side of the equation, we have to do to the other side as well. So on the left side, negative 3 divided by negative 3, that's equal to 1, or they cancel each other out, leaving us with an x. And 27 divided by negative 3, that's equal to negative 9. So negative 9 is our solution to the equation. So essentially, we're saying that if we input negative 9 into our equation where we see x and solve the left side of the equation, it's going to be equal to the right side. Does that work? Let's check. And again, when we check, we do our left side, right side setup check. Okay, so we set up our table, left side, right side of the equation. The left side of our equation had the 2 bracket x minus 3 minus 5 times x plus 2. The right side had 11. Notice that there's no equal sign indicating equality between the left side and the right side. We're checking this with the value of x. And now we're going to input x equals negative 9 into our equation and see if the left side equals the right side. Okay, so we have 2. Instead of putting x, we're going to input the negative 9 minus 3 minus 5 times negative 9 plus 2. Again, the right side still equal to 11. Let's simplify our left side. So we have 2 times negative 9 minus 3, that's negative 12, minus 5 times negative 9 plus 2 is equal to negative 7. 2 times negative 12 is negative 24. Negative 5 times negative 7, that's equal to negative 35. Oh, sorry, positive 35, because the negative times the negative is going to give us a positive. And then negative 24 plus 35, that's equal to 11. Yep, our left side equals our right side, which means that x equals negative 9 is correct. If we had input our value of x into the equation and the left side was not equal to the right side, that means that that value of x that we found is incorrect, or we did something wrong above. Okay. So that's what it means to solve an equation. And generally, a linear equation is what we solved, but this applies to any type of equation that we're solving. Also, note that we did some solving of equations when we had a system of linear equations that instead of having one unknown to solve for, we actually had two unknown values to solve for. To solve these systems of linear equations, we use the graphing method, the method of elimination, and the method of substitution, which we're not going to review because that you did that in the first unit, the linear system unit. Okay. Note, in that unit, you had two unknowns, and in order to solve for those two unknowns, you needed two different equations, right, that had x and y. If you are only solving the equation with one variable, you only need that one equation. But for an equation that has two unknown variables, right, an x and a y or an a and a b, then you're going to need a second equation in order to help you solve, which is what we did in the first linear system unit. Okay, so now that we have reviewed solving equations, let's move on to solving quadratic equations, right? And when we were factoring, you saw some quadratic equations, but now we're going to define what a quadratic equation is. Quadratic equations are second degree equations. Any quadratic equation can be written in the form ax squared plus bx plus c is equal to 0. Okay. Second degree, because if we look at our terms, the term with the highest degree is the ax squared term. And we said that, or when we were defining the degree of a polynomial, we said that the degree is equal to the degree of the highest degree term. Okay. So the ax squared term is the highest degree. This has a degree of 2. The bx has a degree of 1 and the c has a 0 degree. So the overall degree of your equation is going to be 2, or second degree. We call this form of a quadratic equation standard form. And later on in this course, we are going to look at other forms of a quadratic equation. But for right now, we are only learning standard form. In standard form, your a, b, and c values, a, b being the coefficients of your x squared and your x variables respectively, and c being the constant, are all real numbers. So they can be whole numbers, they can be integers, they can be rational values, and they can also be irrational. Okay. But we need to note that your a coefficient cannot be 0, because if it is 0, 0 times x squared, that's going to give us 0, eliminating that x squared term. And if the x squared term is not there, then it's going to make your expression not second degree. So that x squared term has to be present in order for this to be a quadratic equation. So let's look at this example. We have x squared plus 3x minus 4 equals 0. This is an example of a quadratic equation. Notice the x squared term. But in this case, your a coefficient is a 1, the b is a 3, and the c is a negative 4. So whenever we are trying to identify quadratic equations, look for the x squared term. And also notice that there's only one variable, x, right? You have an x squared and an x. So if there was an x and a y, or if there was two variables, doesn't have to be x or y, then this would not be quadratic. That's a lie. Okay, so solving a quadratic equation, like any other equation, means to find the value of the variables that satisfies the equation, which is called the solution, right? So we're trying to figure out what value of x can we input into the equation to make the left side of the equation equal the right side, just like what we did above. The value of the variable that satisfies the equation is also referred to as the root of the equation. In some of the practice questions that you guys will be doing, you will see terminology used as root, or you will see the terminology root used to define the solution of the equation. Just note that root and solution are interchangeable, right? The root is the value of x that satisfies the equation. The solution is also the value of x that satisfies the equation. So root is equal to solution. Depending on the equation, a quadratic can have two solutions, one solution, or no solutions. When we were solving linear equations, there was only one value of x that satisfied the equation. But now in solving quadratic equations, there can be two values of the variable that work, or one value, or no values at all. Now we answer the question, how do we find the solutions of a quadratic equation? If a quadratic equation has one term with a variable x, we can solve the equation using inverse operations, like what we did in the first solving question that we covered in this lesson. So it's by rearranging our equation, isolating for the variable, and then figuring out what our x value is. Okay, so again, whenever we are solving our equations, we want to make sure that our equation is expressed in an expanded and simplified form. So if there's multiplication of a polynomial times a polynomial, we are going to expand that out. Okay, so we have 3 times 2x squared plus 4. Let's expand that to give us 6x squared plus 12, which is equal to 2x squared plus 16. I am choosing to keep my x squared terms on the left and my constants on the right. So I'm going to bring the 2x squared to the left and move the 12 to the right, remembering to change the signs as I bring them to opposite sides of the equation. Equal sign, sorry. So you have 6x squared minus 2x squared is equal to 16 minus 12. So my two terms are positive on their respective sides of the equal sign. As I move them to opposite sides, they change to negatives. And I'm going to collect my like terms. So 6x squared minus 2x squared, that's equal to 4x squared, equals 16 minus 12, that's equal to 4. Dividing both sides by 4 to eliminate the 4 being multiplied to the x squared. Let me move my work up here. So I have x squared equals 1. Square rooting both sides to get rid of that square on the x. I have x is equal to 1. Or negative 1. Whenever you take the square root of a number, always remember that there's two possible values for the square root, right? It's either the positive or the negative, right? I could have also written plus or minus 1. So that's something that you have to be aware of. Whenever you take square root of a number, you have two possible values, the positive value or the negative value. Why? Because in this case, if we had 1 squared, that's going to give us 1. And if we have negative 1 squared, that is also going to give us 1. Okay, so plus or minus 1 is our solution to that equation. But unfortunately, it is not always possible to apply inverse operations to isolate for x, simply because in a quadratic equation, there are multiple terms that have the variable x in it, making it more difficult for us to isolate. Consider this equation that we have here. 5x squared minus 7x minus 6 is equal to 0. If I wanted to isolate for x in this equation, okay, well, I have the x squared x, and I have this x here. Okay, let me try isolating. 5x squared minus 7x. Let's move that constant to the other side. Okay, it kind of looks like our x's are being isolated, but which x am I going to isolate? The x squared x or the x? Right? They're both the same x, but I need to isolate for one of them in order to solve. Okay, let me isolate for maybe the negative 7xx. Okay, so I'm going to move that 5x squared over 2 equals 6 minus 5x squared. Okay, let me divide both sides by negative 7. X is equal to 6 minus 5x squared over negative 7. Okay, what's that value? What's 6 minus 5x squared all divided by negative 7? Well, if I don't know what the x on the left is equal to, how do I know what x squared is equal to, right? We can't solve using this method because we still have an unknown on the right side of our equation that can't help us figure out what the value of x on the right side is equal to, because that is also unknown too. So we have to apply another method. To solve for x, we can factor the equation and then solve. So once again, our equation is 5x squared minus 7x minus 6 is equal to 0. Pause this video and try applying our factoring methods, whichever one you think you're going to use, on factoring this. I'm not going to spend too much time going over the concept of factoring because, again, we should be masters at factoring. But if we factor this correctly using the methods that we learned previously, we will get 5x plus 3, x minus 2. So as we do these solving problems, less emphasis is going to be on the actual factoring itself and more on the solving. So pause the video, try the factoring, check with the video to see if your factoring is correct, and then we're going to move on to the solving. Okay, but if you factor correctly, you should get 5x plus 3, x minus 2 is all equal to 0. So we're just expressing the polynomial expression on the left side of our equation in factored form. Our equation says that the product of these two binomials is equal to 0. In order for this equation to equal 0, three things can occur. The first is that the factor 5x plus 3 is equal to 0, because if we set 5x plus 3 equal to 0, we will have 0 times x minus 2 is equal to 0, and 0 times anything is equal to 0. Yep, that works. Or, in order for this equation to equal 0, the x minus 2 factor can equal 0, right? If we have 5x plus 3 times 0, because we set the x minus 2 factor equal to 0, that's going to give us 0 too. Or, if both of our factors are equal to 0, 0 times 0 is equal to 0. Yep, that works too. So the question is, what value of x will make our factors equal 0? And because whether or not the first factor is 0 or the second factor is 0, in both of those scenarios, your equation is equal to 0. So there is two possible values of x, because you're going to require two different x values to make each of your factors equal 0. So in order to solve this equation, we have to set both of our factors equal to 0 and solve for x. So we have 5x plus 3, and we're going to set it equal to 0. And solve for x. So we're going to move the 3 to the other side, leaving us with 5x on the left and negative 3 on the right, then divide both sides by 5. And that's going to give us negative 3 over 5 is equal to x. For x minus 2, we set that also equal to 0 and figure out what value of x will make this factor equal 0. So x equals 2. So the two solutions to this equation is -3/5 and 2. Because the -3/5 is going to make the 5x plus 3 factor 0, and the 2 value for x is going to make the x minus 2 factor equal 0. Let's check to make sure that these solutions are correct. So for case 1, x equals -3/5. When you have two solutions to your equation, that doesn't mean that you're putting in two different values for each x, one for each factor. It's either you're going to substitute in the x and check, or you're going to substitute in the, you're going to substitute in the x equals -3/5 and check, or you're going to substitute in the x equals 2 and check. So let's check using the x equals -3/5 solution first. So remember, our original expression or equation was 5x squared minus 7x minus 6. And on the right side of our equation, we had equals 0. Substituting in x equals -3/5 into this equation, or expression, we get 5 times -3/5 squared minus 7 times -3/5 minus 6. And then we evaluate to see if it's going to equate to our right side. 5 times 9/25 minus or plus 21/5 minus 6. Well, 5/25, that's going to leave us with a 1/5. So that's going to be 9/5 plus 21/5, and then changing this -6 to a fraction with a denominator of 5, that's going to give us -30/5. So 9/5 plus 21/5 minus 30/5, that's equal to 0. So left side equals right side. So x equals -3/5 as a solution works. Let's try the second solution. Again, we set up our equation, 5x squared minus 7x minus 6 on the left. On the right, that's equal to 0. But this time, we're substituting in 2 into the equation to see if it works. 5 times 2 squared minus 7 times 2 minus 6. Okay, and we evaluate. So 5 times 4 minus 14 minus 6 is equal to 20 minus 14 minus 6, which is equal to 0. If I went too quickly over that evaluation, just pause, try it for yourself, and then watch to see if your solution is correct. But again, the whole thing is to make sure that you are applying BEDMAS, right? We're applying our exponents first, and then our multiplication, then our subtraction. And again, our left side of our equation is equal to the right side, indicating that both of our solutions, x equals -3/5 and x equals 2, satisfy the equation. So they are both solutions to our quadratic equation. So in general, the steps for solving a quadratic equation by factoring is 1, you're going to expand, simplify if needed for the equation, and rearrange the equation so that it is in the form ax squared plus bx plus c equals 0. So all of your terms on one side of the equation, right? Making sure to expand and simplify if needed. Next, you're going to fully factor the equation using a factoring method. Again, where master's at, GCF, trinomial factoring, difference of squares factoring. And then set each factor containing the variable equal to 0 and solve. Let's do some practice questions. Note once again that we're not going to spend too much time on the factoring sections of each of these solutions, but mostly on finding the value of x. So pause the video whenever we start factoring, try the factoring on your own, and then check with our factored form to see if you factored correctly. The first example is the example that we used initially when we solved our quadratic equation using the inverse operations method. This time, we're going to be using the factoring method. So once again, we expand and simplify our expression to give us 6x squared plus 12 equals 2x squared plus 16. But this time, we are going to move all of our terms to one side of the equation so that our equation is set equal to 0. I'm going to move all my terms to the left. 6x squared plus 12. Everything that was on the right side will now have an opposite sign. Minus 16 equals 0. Right? Rearrange the equation so that all my terms are on one side, meaning that the other side of the equation is equal to 0. Then I collect my like terms. So 6x squared minus 2x squared is equal to 4x squared. 12 minus 16 is equal to negative 4. And that's all equal to 0. Next, we are going to factor. And again, pause, factor, and then check to see if the factored form is correct. But when I factor, first I'm going to apply GCF. So 4 is the greatest common factor, leaving me with x squared minus 1 in the bracket. But then within the bracket, this is a difference of squares, so we can factor again. Please make sure that you are factoring fully. 4, x minus 1, x plus 1 is equal to 0. This is my factored form of the equation. Next, we set all of our factors equal to 0. What are our factors? Well, the 4 is a factor, the x minus 1 is a factor, and the x plus 1 is a factor. But the 4 factor doesn't contain an x value, so we are going to ignore that. All right, the other two factors, if we input some value of x into each of those factors, they could potentially equal 0. So what is the value of x that will make each of those factors equal 0? Well, for the first one, x minus 1 equals 0. Well, x equals 1 in order for this factor to equal 0. And for the second factor, x plus 1 equals 0, x has to equal negative 1 in order for that factor to equal 0. So our two solutions are x equals 1 and x equals negative 1. We would check this by doing left side, right side check with both of our solutions to see if it satisfies the equation. Let's try the second example. We have x all times x minus 6 equals 4 times x plus 6. We want to expand, simplify, and then rearrange the equation so that the equation is set equal to 0. Again, not spending too much time on the factoring part. X squared minus 6x. Oops, I just want to use a different color. Okay, x squared minus 6x equals 4x plus 24. Moving all my terms to one side of the equation, I have x squared minus 6x minus 4x minus 24 is equal to 0. Collecting my like terms, I have x squared minus 10x minus 24 is equal to 0. Factoring my equation, I have x minus 12 and x plus 2. Check if you don't believe me. Stop the video, try your guess and check method, but when you do, it will factor into x minus 12, x plus 2. Next, we set our factors equal to 0. So x minus 12 is one factor and x plus 2 is another factor. Remember, to identify factors, factors are separated by multiplication. So the x minus 12 is being multiplied to the x plus 2. So both are individual factors of our original expression that was factored. Setting each of those factors equal to 0, we get x equals 12 and x equals negative 2. So you're solving each of those equations individually, and x equals 12 and x equals negative 2 are our solutions. Again, to check, you would substitute each x value into the equation separately. and see whether or not the left side of your equation equals the right side of the equation. For this example here, instead of moving our terms to the left side of the equation, let's move them to the right side. And again, I would choose to do this simply because I have more terms on the right than I do on the left, but it doesn't matter what side you choose to move your terms to. Okay, so just trying to be different here. We have 4t squared minus 8 plus 1 minus t plus 4. So whatever you're moving to the opposite side of the equation, you got to change the signs. So whether you move your terms to the left side or you move them to the right side, it doesn't matter as long as the equation is set equal to 0 on the left or on the right. Collecting our like terms, we have 4t squared minus t, negative 8 plus 1 plus 4 is equal to negative 3. So this is a complex trinomial. We're going to factor this using guess and check. And when you factor this, you should get t minus 1 and 4t plus 3. My t's look like plus signs. Okay. So this is our factored form. Now we need to set each of our factors equal to 0. So t minus 1 equals 0 and 4t plus 3 equals 0. And we're going to solve each equation. So t equals 1 and 4t equals negative 3. Divide both sides by 4. Negative 3 over 4 is equal to t. Okay, so when you solve these, you can also get a solution that is a fraction or a rational number. Okay, again, if we substituted both of our expressions, if we substituted both of our solutions into the original equation on the left side and the right side, one at a time, starting with t plus 1, the left side would equal the right side, showing that both are solutions to the equation. Last one that I want to show you includes fractions. And again, fractions can be intimidating for us, thinking back to grade 9, but again, this is quadratic because of the x squared term. In order to simplify this expression, we decide to use the magic number. And hopefully you remember that magic number that will eliminate our denominator or the need for the denominator in the equation. What is our magic number? Well, looking at all of our terms, the denominator in the first term is 6, the denominator is 3 in the second term, and then we can put a 1 at the denominator of our term on the right side of the equation. The lowest common multiple between all of these numbers is 6, so we're going to multiply each term by 6. So the first term times 6 is going to eliminate the denominator 6, leaving us with the x squared. When we multiply the second term by 6, we're going to be left with 2 times 4x equals, multiplying the negative 2 by 6, we have negative 12. Again, slow this video down, stop it, try it yourself, and then figure out where these numbers came from. Okay, this is a quick review of simplifying for our with fractions. Okay, when we simplify and move our terms to one side of our equation, we have x squared minus 8x plus 12 equals 0. Factoring this expression gives us x minus 6, x minus 2, all equal to 0. And then solving each individual factor set equal to 0, we get x equals 6 and x equals 2. Easy breezy, even with fractions. So that is how we solve quadratic equations using the factoring method. In the next video, we're going to be looking at solving quadratic equations that are not factorable. What do we do then? The homework that is assigned is from section 5.2 in the textbook, page 282 to 283, number 1, all the questions, 4 to 6 all, and 8 to 10 alternating problems. So if it's A, B, C, D, then you can do A, C, dot, dot, dot.